Hey everyone, welcome back to my channel. Today we are going to solve Cambridge International AS and A Level Pure Mathematics 1 Paper 1-2 from Feb March 2025. So let's get started. And here is a question number 1. A curve has equation y equals 5 plus 3x minus 2x squared, and a straight line has equation y equals kx plus 13, where k is a constant. Find the set of values of k, set of values, so there would be more than one value of k, or maybe the inequality for the k, for which the curve and the line do not meet. So we know that whenever we have to talk about the intersection of the two functions, maybe that is one is a curve, another is a straight line, or maybe both of them are a straight line or curve. So we should start with by equating both the equations here. So if we equate both the equations, we will get 5 plus 3x minus 2x squared, and this equals to kx plus 13. So basically I did y equals y, and then we got this equation, and we can, as we can see, that it is going to be a quadratic equation. So we need to write in the standard form of the quadratic equation ax squared plus bx plus c type, where a, b and c are the constants. So here if I want to write in the standard form of quadratic equation, it's better to send this negative 2x squared term to the other side and make it as 2x squared positive, and then there is a positive kx, and then this is going to be minus 3x, and then it is plus 13 minus 5. So basically I translated everything from the left hand side towards the right hand side, and then we got this as a 2x squared plus k minus 3x plus 8, 13 minus 8 equals 0. And now since we are going to solve it for do not meet, and this is a quadratic equation, so we know that quadratic equation has no solution. So basically when we have a quadratic curve and a straight line, when they don't meet, it means we are technically finding the solutions when they are intersecting. And here if they are not meeting, it means they should not have any solution, and for no solution we know that the b squared, the discriminant delta, should be less than 0. So from here the discriminant, which is b squared minus 4ac, and here b squared is the second term, coefficient of x, k minus 3 whole squared, b squared minus 4 times 2 times 8, this has to be less than 0. So if we'll simplify this, we are going to get it as k minus 3 whole squared minus 64 less than 0. So it's a quadratic inequality. We have two ways to solve. I can see it is going to form a complete, like a difference of a square. So I will rewrite this thing as k minus 3 whole squared minus 8 squared is less than 0. The whole point of doing this, solving, like how to solve the quadratic inequality, it's like when you now find the root of the like corresponding equation, we can figure out where it will go, what all values k can hold for which this whole equation will be less than 0. So here I can rewrite this thing as, since it is a squared minus b squared type, which is in one bracket a plus b, another bracket a minus b. So the a here is k minus 3, so it is k minus 3 plus 8, and in another bracket k minus 3 minus 8 less than 0, or this is k plus 5 into k minus 11 less than 0. So now we got a we can find the solution of this. If we consider this is a quadratic equation, then we have the two solutions, negative 5 and positive 11, and then we'll draw the graph to make it more clear. So if we see this curve, coefficient of k squared is positive, so it is going to be cup-shaped curve, and hence we got two solutions here as negative 5, and here it is positive 11. That's the whole point of writing in this way. And since we need to find the values of k for which this is going to be less than 0, so we can see for this region these values of x or k, the curve is below the x-axis, technically less than 0. So we can say from here that k has to be more than -5 and less than positive 11. So these are the set of values for k for which the curve, the curve 5x y equals 5 plus 3x minus 2x squared and straight line y equals kx plus 13 will not intersect. Here is question number 2. So the diagram shows the curve with the equation y equals 2x squared minus 5 over x plus 3. The curve crosses the x-axis at the point p 1, 0 and m is the minimum point. Find the question is to find the gradient of the curve at p. So P is the point here. We can see if we want to find we know the gradient of the curve at any point is basically same as finding the gradient of the tangent drawn at that point of the curve. So we are going to use the calculus here because we know the derivative function, derived function dy over dx will give us the gradient of the curve. So here the y is the curve, equation of the curve is y equals 2x squared minus 5x plus 3. So we are simply going to use the power rule and we'll find the dy over dx. So dy over dx is going to be, we can rewrite this equation again. So y can be written as 2x squared minus 5x to the power -1 plus 3. So here this dy over dx from here, which I'm going to use, the rule I'm going to use is, if we have an equation of the form x to the power n, the derivative would be n x to the power n minus 1. So multiply by the power and reduce the power by 1. So this is going to be 4x minus n to minus 5 into -1, it is going to be positive 5 x to the power -2 and constant, so it is going to be 0, and hence dy over dx is this, or we can rewrite this thing as 4x plus 5 over x squared by using simply laws of exponent, and hence the gradient of curve at p, which is 1, 0, is going to be dy over dx at x equals 1 here, because in the dy over dx we don't have y, so I'm just writing x equals 1, and hence this is 4 times 1 plus 5 over 1 squared, which is 4 plus 5, that is 9, and that's a gradient of the curve at point P. I hope it is clear. Let's discuss the B part of it. And the B part is find the coordinates of M. Give your coordinate correct to 3 significant figures. So as we know from the question, the information given that M is the minimum point, local minimum. So again, for we know that dy over dx, which is the gradient function, that is going to give you the gradient, and at the stationary point or maximum or minimum point, the dy over dx, because the gradient is going to be 0, so we can simply say at m dy over dx has to be 0, and we got the gradient dy over dx as 4x plus 5 over x squared, and if we equate equals to 0, then we'll simplify it like to find the value of x. So I can rewrite this thing as 4x cubed plus 5 equals 0. So I simply multiplied the whole equation by x squared, and because x is not 0 of course, and hence we got 4x cubed equals -5, or x cubed equals -5 over 4, and when we know that it is cubed, so the x value would be the cube root of -5 over 4. Value is -1.0772 and so on, and since we need to write our answer correct to 3 significant figure, we will write the x equals till 3 significant figure, this is going to be -1.08, and since we got this value in the calculator, so it is going to be stored in the key answers. So we will use the same value as the answer, and see, since we need to find the coordinates, so y, which is given as 2x squared minus 5 over x plus 3, we'll plug this in the calculator. In the calculator we are going to write the, in place of x we are going to replace this with the answer, and then we'll write everything and we will get the answer directly from the calculator. But here for just writing, I am taking the initial value, not the corrected value, so I'll take it as I'll write negative 1.0772 dot whole squared minus 5 over negative 1.0772 dot plus 3. And after solving it from the calculator, because solving it from the calculator is going to be very easy, because we are just going to replace the x with the answer key. So this value I'm getting is 9.9623 and so on, and that's going to be the y value, but we need to write the answer correct to 3 significant figure, hence this is going to be 9.96. so the coordinates of m are negative 1.08 comma 9.96. so that's the answer. I hope that's clear. Let's discuss the next part. And here is the question number 3. A part, find the complete expansion of 2x minus 3x to the power 4. Since we have two options, one is the binomial expansion, another one is the Pascal triangle. Way better to use the Pascal triangle than the binomial expansion. Till power 6 we can remember the Pascal values, Pascal triangles, so it would be very helpful. And we know that for 4 the Pascal triangles, the values are 1, 4, 6, 4, 1. So the expansion would be according to the, of course when it is negative sign means the, again every alternate values would be negative, every alternate term would be negative starting with the positive value. So it is going to be 1 times 2x to the power 4, then minus 4 times, because that's the second value, 4 times 2x to the power 1 less 3, and the second is 3 over x, plus this next value which is 6, and this is going to be 2x to the power 1 more, again it got lesser, another one gets bigger, so it is going to be power 2, and here it is going to be 3 over x to the power 2. Next is negative because of this sign, and value is 4, and hence it is going to be 2x to the power 1, and this second term 3x to the power 3 over x to the power 3. And finally it is going to be positive 1, 2x to the power 0, so I'll not write, and hence it is going to be simply 3 over x to the power 4. So now we will simplify it. This is going to be 2 to the power 4, laws of indices. We know a b to the power n is a to the power n, b to the power n. So this become 16 x to the power 4, and this is minus 4 into, this is going to be 8 because the power is 3. So 2 to the power 3 is 8, 8 into 4 into 3. So it's basically 12 into 8, and 12 into 8 is 96. X to the power 3, here it is x to the power 3, and this is going to be denominator. So here it is going to be plus, I will write 6 into 2 to the power 2, so it is going to be 6 to the power 6 into 4, which is 24, and 3 squared is 9, and here it is going to be x squared, and denominator is also going to be x squared. And here it is going to be minus 4 into 2, 8, 8 times 3 cube, which is 27, and this is x, and denominator is going to be x cubed. And finally it is 3 to the power 4, which is 81, and denominator is going to be x to the power 4. Now we'll write in the simplified form using the calculator to calculate the value of the multiplication. It is going to be 16 x to the power 4 minus 96 x squared plus 24 into 9, 216, and this x squared got cancelled with x squared, so it is like a constant coefficient. And then 8 into 27, that is also same as 216, and if we cancel with this, so we will get denominator as x squared and plus 81 over x to the power 4. So that's the final expansion of the 2x minus 3 over x to the power 4. So and then it is very obvious question. Most of the time they ask the same type of questions in the pure mathematics one. So it's like hence, so we are going to use this anyhow. Hence, determine the coefficient of x squared in the expansion of x squared plus 5 into the same number, same expansion we can see. So if we are finding the coefficient of x squared, we know that if we multiply this with constant term, we'll get coefficient of x squared, or we multiply 5 with, in the another bracket, 5 with coefficient of x squared, then only we'll get the x squared term. So we'll rewrite this whole thing just mentioning only those values which we need, or we can write the whole thing once and then we can decide. So it is going to be, we could have simply written this value, this term and this term, because that's what we need. And so we will write the rest of the terms. If you're not writing, we can simply write the dot dot dot, and hence this, if you multiply x squared with 216, so this is going to be 216x squared, and if you multiply 5 with negative 96x squared, so minus 480 480x squared, and plus dot dot dot, so and so on. We don't need those terms. So 216 minus 480 is going to be negative 264 x squared, and hence this means coefficient of x squared is negative 264. So that's the answer. So that's it for this video. Let's discuss the rest of the questions in the next video. Till then, thank you so much.